Good afternoon, everybody. How you doing? My name is Warner. We are going to be going over production quality 3D printed parts with SLS and SLA technology, which is selective laser sintering and stereolithography. So a little bit about WB Engineering before we get started. So we're a product design and development company. We were established back in 2007. Our business verticals are product design and development, specifically in medical devices, consumer products, mechanical design, and we've even done a lot of product optimization for products that are already out on the market and need refinement, either for reliability, decreased cost, increased margins, things like that. In addition to that, we are also partners with 3D Systems and with Autodesk. So our motto basically is we will either empower your company to be designers with the highest tech available, or we can be your outsource for engineering. So I'm going to give you the perspective of a user of 3D printing. We use it day in and day out here for our product development process, which is what helps us compete with much larger companies with much more overhead. We essentially have, super powered our engineering staff with 3D printers and full suite of simulation software in order for them to be able to accomplish a significant amount of work without having to increase our headcount here. So a little bit of background about 3D Systems. So 3D Systems is the originator of 3D printing. So 3D Systems invented 3D printing about 3 years ago and is still the leading provider of 3D printers. They also provide software and services as well. The company is headquartered out in Rock Hill, South Carolina, and they are the company that has the most vast portfolio of 3D printers available. So just go through the history a little bit. SLA was the first type of technology that was commercialized in 1988. Then 3D Systems invented selective laser sintering, which is the other technology that we're going to be going over, in 1992. Then 3D Systems invented color jet printing. I'll put a little asterisk on the end of that. Actually, it was a company called Z Corp, which was then acquired by 3D Systems. Therefore, by default, now 3D Systems can say they invented that. And that was in 1994. And then multi-jet printing, which is the webinar we had last time. That was invented by 3D Systems back in, first invented and commercialized back in 1996. So they invest heavily in R&D, and that's actually the reason why we chose to be a partner with 3D Systems over the other 3D printing companies that are available in the professional level of 3D printers. Okay, so before we get started, I'd like to learn a little bit more about our audience today. So I'm going to be putting up a poll, and if you guys can answer, be greatly appreciated. So we want to know, do you guys currently use, and ladies, do you currently use 3D printing? So we want to know, do you use it in-house? Do you have a 3D printer in-house? Do you outsource it? Do you do both? Or do you not use 3D printing at all? So we'll wait a little bit until everybody gets their answers in. Looks like we almost have everybody in. Okay. So thank you very much. Appreciate that. I'm sorry, let me, before we jump into this, so we're going to run a little video here just to introduce 3D printing.
In broader sense, you might say it does for engineering and manufacturing what the Xerox machine or the word processor or both of those do for the office.
Selected 3D Systems because of history, the fact that they really are the inventor and the establisher of this technology.
Many things that we do now within a day, 2 days, would take months
Okay, so now back to the presentation. That was a quick intro there. So why 3D Systems over any other 3D printing companies? So they have a global footprint. They are also one of the technologies that, one of the companies who invest significantly in R&D, which again, that's one of the reasons why we chose to go with 3D Systems. They invented the technology 30 years ago. They have the broadest line of 3D printers. Therefore, you know, if you work with one type of technology, you can also start broadening your portfolio of 3D printers within the same company with the same level of support that's been around for a very long time. So you're not getting in bed with somebody who just started in the industry, right? So they have an established support system, and these printers, in a lot of cases, especially in the two cases we're talking about today, have been around for many years as well. So they're just extremely robust versions of what they were, you know, 20 years ago or 30 years ago. So 3D printing in 3D Systems is very, very vast, right? So they have printers starting with the Cube Pro, which is a plastic jet printing technology, all the way up to a Pro X 400, which would be a direct metal printer, and everything in between. Specifically, we'll be talking about today SLS and SLA. Is the product list of the printers. So these are the main lines of printers that 3D Systems has. Within these, there are different derivatives of them, but we're going to be talking about a couple of the ProJets today, which would be the ProJet 6000 and 7000, which are our professional level SLA systems. And then we're going to be talking about the production SLA systems, Pro X 800, the Pro X 950, and then the SLS systems, which include the Pro X 500, and then the iPro series as well. So I'm going to ask another quick question here, just to make sure that we learn a little bit more about our audience. So we want to know, are you guys currently looking into purchasing a 3D printer? Is it something that you've already budgeted for and have some immediate plans, or is this something that we're just doing some research on for right now? So it's good to know how to kind of cater the presentations. I don't want to bog you guys down with too many commercial details when what you guys are really here for is just doing some research and getting to learn the technology. Okay, so I'll just wait a couple more seconds. All right, thank you everybody, appreciate that. So now we're going to jump into stereolithography. Again, this is the original 3D printing technology that was established 30 years ago, and now we're going to get into those details here. So stereolithography, again, was invented by Chuck Hall a while ago. 3D Systems has been steadily refining and improving upon this technology for 3 decades now, and has dozens of high-performance materials that are available. Additionally, you have the benefit of the history behind this technology. They're much more reliable nowadays, and they are exceptionally good for manufacturing of ergonomic parts and other small parts. So I actually wear a product called Invisalign. Those are actually full custom, let's say, clear retainers. Those are all made via 3D printing. So it's pretty amazing to see how 3D printing now is doing manufacturing, not so much just prototyping. So it's jumping over to actually getting into the manufacturing room, which is pretty exciting. Okay, so that was a quick video about SLA. So again, this is the family of SLA printers via 3D systems. So starting from the ProJet 6000 SD all the way up to the ProX 950. All of these have very, very similar print quality, with the exception of the SD models, which are slightly lower resolution. But then once you get into the HD and MP versions, you're going to get basically the same kind of resolution and part quality across all four of these systems. The only difference is build volume, capacity, throughput, and material options as you go from one model to the next. But in terms of part quality, you're getting basically the same part quality from a ProJet 6000 as you would from a ProX 950. Again, the main difference is build volume and material availability. So why choose an SLA 3D printer, right? So it's one of the go-to 3D printers when you're going to be doing large parts or have very large throughput, when you want the highest resolution period, the best surface finish period, and also when you want to have the broadest range of materials. So this printer is great for extremely small parts with very high resolution. It's also very good for very large parts with high resolution as well. So whether it's a lot of small parts you're printing out or a couple big ones, this is a good printer to look at because of its low cost of ownership and low cost to produce parts per unit. So what are the ideal applications for SLA 3D printing? So since it does have the broadest range of materials in additive manufacturing, the large choice of available material properties enables you to have the broadest range of applications of any additive manufacturing technology. Customers can choose from dozens of different materials for mechanical properties, specific optical specifications, high temperature applications, and then you can switch from one material to the other very easily. The materials for SLA printers are actually grouped up into several different classes. Those would be polypro class, an ABS class, a durable tough class, a clear class, a high temperature class, and then there's some specialty classes just like composites, which are ceramic filled materials. So just in the images that we're showing above, there's a mode on the ProX SLA systems that allows you to do this mode called quick cast, which you can actually then do large engine blocks and cast those directly off of an SLA part. We do also have high temperature material, so if you want to use the material directly off of the 3D printer for a high temp application, you can do that as well. There's biocompatible material so that you can actually use these for surgical guides. There's tough material, optically clear material, durable, things like that. So there's a wide range of materials. Not to mention you can then do secondary post-processing to these materials as well. So these parts take paint very well, you can electroplate them very well, and you can tap them, sand them, different types of secondary post-processing you can do to it. We have one customer that is actually looking into purchasing a ProX 800 to actually do end part production off of that system, and then powder coating the parts after the fact, so you'd be none the wiser. So the other thing is SLA offers the best part quality and surface quality, period, right? So if you're looking at any other technology, including technologies within the 3D Systems portfolio, if you want the best quality part in terms of accuracy and precision, you are looking at an SLA system. I would say second in line to that would be our MJP printers, and then from there on out, the printers get a little bit less precise, and the surface finish isn't quite as pristine as on these two different types of technologies. So with SLA, you get both smooth surfaces and sharp edges. You know that everything's going to be very good in terms of quality. It even rivals, machined CNC parts in terms of precision. It exceeds in a lot of cases the precision of injection molded parts. If you're going to have issues with warping and things like that, when you injection mold a part, you don't have those kinds of issues when you actually SLA a part. The other thing is SLA post-processing is actually significantly less than what you would find on, let's say, an FDM style printer, right? You have very, very smooth finishes, and the removal of support is actually very minimal. So let's talk a little bit more about the unmatched accuracy that SLA has. So the accuracy is a combination of the printer's given capability plus the properties of the material that you're putting into it, right? So there are some materials that you can run in these that are extremely precise, and then other materials that are still very precise but not quite as sharp as other materials, right? So the accuracy of your part will vary slightly with the type of material you load on your printer, and then obviously the build mode that you're using, whether it's a draft mode to go fast on, or if it's a HD, high resolution print that you want to go a little slower on. In essence, though, you're looking at plus or minus 45 microns of accuracy for any print location, print to print, or machine to machine. So it's very, very reproducible results that you can get from these parts. So you don't have to worry about running a part and then having to run it sometime down the line. As long as your printer is calibrated, you will get the same kind of part off of it day to day, print to print, and machine to machine, right? So if you have another machine at another facility, you need to print it out, simply email the file over. They can then print it out with the same level of precision. Furthermore, you can actually reproduce very, very small features down to 0.05 millimeters or 2/1000 of an inch, depending on the geometry, the build mode that you have, etc. So in this example, actually, this is an electrical connector, and it shows components that have very thin walls. In this scenario, that's actually 1/4 millimeter thick. This is something that's going to be built, or I'm sorry, was built for an initial manufacturing run of 2,000 units for an automotive supplier. So it actually ended up saving that company tens of thousands of dollars in tooling and modifications, because they're able to print them out, modify as they go without having the expense and the time associated with an actual traditional steel tool for injection molding. A little bit more about the unmatched accuracy that these printers have. You'll notice that in this scenario, this is an extremely small part with very small holes in it, and you'll notice that the gaps between the hexagon is actually 0.175 millimeters or 7/1000 of an inch. So you have extremely, extremely thin walls, and it holds its detail with very small geometry. So just to continue on that fact, this part, for example, as you see in the person's hand, is extremely, extremely small. The walls are actually 0.125 millimeters, and the hole features are very, very small. So SLA is very good for small, small parts. Also, now that we're convinced that this is a very precise machine, we also want to look at how much throughput can we do, right? Because a lot of the times people, they look at these larger printers not so much because they want to print large parts, right? Especially in our industry, for example, we do a lot of consumer products and medical devices, of which 90+% of them fit on our small ProJet 3600. When we do need bigger parts, we will go to a SLA system with bigger capacity. But in most cases, what we would do is when we go to the SLA systems, it's when we're actually running several parts at the same time, right? The other thing is SLA is very inexpensive to run large parts, or parts that would be very expensive on a multi-jet printer are actually very inexpensive in an SLA system. So a couple things to point out here is very minimal support structure. You'll notice there's a little bit of support on these parts here, which is actually indicated in this area right here where my laser pointer is. So you notice there's very, very little support structure created for this entire part. In some of our technology, it would actually require for this entire area down here to be filled with support. So that would be something that would be costly on, let's say, a multi-jet printer, where with an SLA printer, very inexpensive to produce these. The other thing is, this is 28 automotive electronic doors, covers, I'm sorry. They took 32 hours and 20 minutes to print on a Pro X 800. That means it's only about an hour, 10 minutes each, and they only cost $16.20 to produce them in terms of materials. So it's very cost effective to be doing low run production parts on an SLA system. And actually, it's really nice to visit the manufacturing facility in Rock Hill, because you'll start to realize how many actual 3D printed parts are on the part that you are on the printer that you're actually going to be receiving. So they don't only preach it, they do it as well. So they actually manufacture some of their SLA parts for their SLA printers off of an SLA machine. Next thing is large parts that are extremely accurate, right? So imagine trying to make the part on the left any other way other than 3D printing. That's a very large, complex geometry. Machining that would be an extremely expensive endeavor, not to mention time-consuming. With 3D printing, the beauty of it is it's actually printing, right? So it doesn't take the man-hours that something like this would take to program, make fixtures, setups, things like that. You simply submit it to the printer and hit print. So these large parts, they came off of a Pro X 950, which is the largest SLA printer available, which can give you extremely high resolution large parts, and it will cut time required for assembly. You can even eliminate part weaknesses associated to attachment points. So continuing talking about large build volume, you can actually print up to 1500 by 750 by 550 millimeters. That's a build volume of 950. So you can do extremely large parts with very high resolution. Again, you'll notice that the support on these parts are very limited. They're not taking up the entire volume. So you notice this internal cavity right here. There's very little vertical support. These little stringy parts, that's the actual support holding this together. So this is the support. This does look very dense from the outside, but actually from the inside, it's very very porous. It's not completely filled in solid. Either way, though, there's very little support on this part. And then also, while you do that, you can also even have extremely small, high-resolution parts on that same build, or on another. On another build later on. So let me ask another poll question here. So we're a little curious about what you are looking to use a 3D printer for, right? So we're going to be talking about how 3D printers can be used for different processes, right? So we know they can be used for prototypes, end-use products. They can be used in a casting process, even tooling, jigs and fixtures, things like that. And we actually do have a couple of customers that purchase them solely for marketing purposes. So they want to, they make large industrial equipment, and they just want to arm their salespeople with a very small scale version of their industrial equipment, or even for internal meetings to give feedback, etc. So yeah, we just want to know who is looking to use these printers for prototyping, end-use parts, casting, tooling, or others. So give me a couple more seconds, and I will close out this poll. All right, thank you, everyone. Appreciate that. So now we're going to have a quick video of SLA to see how this technology actually works. Okay, so if you guys have any questions about anything that we're talking about, feel free to start filling out the questions in the webinar. You can raise your hand, ask questions there as we go. So feel free to ask questions. We don't have to wait till the end. I will fill you guys in as I go. Hopefully I can answer all your questions as we go. So as you can see, the SLA system actually works with a liquid vat of resin, which then gets cured with a laser that shoots into it. The liquid vat is actually something that you can remove. We have these things called MDMs, or material delivery modules. You can purchase a couple of those with a printer. Therefore, if you want to run several different materials, you just simply swap out the material delivery device, and you don't have to worry about setup or anything like that. It's just simply as easy as rolling in a cart and rolling out a cart and rolling in another cart. So they made it very, very easy to take advantage of the diverse amount of materials that are available in the SLA family. So the SLA family from 3D Systems includes, like we mentioned earlier, the ProJet 6000, the ProJet 7000, the Pro X 800, and the Pro X 950. So you'll notice across the board you get the same accuracy, right? So you get the same plus or minus 1 to 2 thousandths per every inch. What you will notice that the printers do go up in volume, right? So you start from as small as 10 by 10 by 10 inches all the way up to 59 by 30 by 22 inches being our largest SLA option. So, summary, again, you have the broadest range of applications because of the large amount of different materials that you have available to you. You have the best surface quality in terms of part, cost-efficient scale-up. So, like I mentioned, I wear Invisalign. That is a mass-produced part. They literally make millions of units a year, and that's off of an SLA system. It's cost-effective. Another thing is unmatched accuracy and resolution. Lowest precision part cost, and then also huge print volumes as well. So let's ask another poll question here. Make sure everybody's not falling asleep after lunch. So for those of you that are actually looking into purchasing a 3D printer in the near future, do you already have a budget, right? So I know a lot of our customers do get sticker shock, being that especially ones that are not too familiar with the industry, you'll see online there's a lot of very inexpensive consumer level printers, right? Ones that are good for making very low resolution parts. We use those in-house too. I'm not going to say we don't. They have their place. And they're actually good printers for what they work for. But when we are designing something that's about to go to manufacturing that needs to be confirmed before we have our customers spend tens of thousands of dollars on cutting steel and also waiting the lead time that's required for that, we always run our parts on a high resolution 3D Systems printer. The reason why is because you need to be 100% certain that the geometry you're producing on your part is one-to-one with the geometry that you expect to see after the fact, right? Even a badly calibrated machine can cause big issues. The reason being is because it could cause false positives and false negatives. For example, you have said widget that needs to fit inside of a hole, and you 3D print it and it fits great. You think everything's good, and it just so happens maybe your 3D printer had a bad resolution setting, or just doesn't have the capability to produce a geometry accurately enough, and you think that your design is perfect, but it's actually flawed, right? So that's one of the things that we like to avoid. We need to make sure that we have the right part. So we don't want to be misled by a part that was printed out that just wasn't quite the size and shape that we needed it. So again, we do day in and day out. We use all different types of printers, and the ones that we use a lot are for quick and dirties are our multi-jet printer, and we use our Cube Pro as well. But when we're going to go to manufacturing, we have to use either a multi-jet printer, which is very high resolution, or an SLA system in order to confirm the precision of our part, make sure that the part that we are going to be producing out of injection molded parts, out of an injection molded steel, it's going to be precise, and we need to make sure that matches up with our design. So now let's move over to SLS, right? So with SLS, this is now tough parts. These parts are made for end use. This is not the type of part that you have to be scared about handing over to somebody and having them accidentally break it. It's just not going to happen. You need to really intentionally and purposely try to break one of these things. So Pro X500 is the one that we're going to be focusing on today. In general, though, our SLS systems do about the same when it comes to print quality, with the Pro X500 being slightly ahead of the rest of the game, but we do have different build volumes if this one doesn't quite fit the bill. But they're very economical to do end-use parts on, and also bridge manufacturing on these parts, which are really nice. Okay, so let's get into an SLS system. So why do you want an SLS system, right? So we just found out that SLA is the most precise, best surface quality that's available. So then why am I looking at an SLS system instead? So SLS system is for really tough mechanical properties, right? So like I said, these parts you can use for end use. Also, these machines are workhorses as well. There's actually several products that are available on the market today that are directly off of an SLS system. One being a recent case study of a gentleman that is actually developing high-end shin guards. And what he did was he actually 3D scanned, I believe, something like 500 different people, got what he believed was an optimized contour to a person's shin, and then now he actually sells these really cool looking shins with very complex geometry and a really nice, intricate pattern on it directly off of his SLS printer. So it's to the point where you can actually 3D print parts as end use and still make a margin there. So where you used to have to invest tens of thousands of dollars in molds, hold stock, do everything that comes along with the traditional way of manufacturing. Now you print on demand as you get orders. Obviously you can hold some stock because 3D printing is not ultra fast, as we will see, but it is something that is very, very good for people not having to hold stock and be very flexible and agile with their designs. The gentleman that does this directly off of an SLS system is literally a day away from a new design that is end-use part, right? So he can have a meeting with his engineers, and let's say his version 2.0 is something they want to work on. Well, if an engineer designs that, makes the modifications he needs to that day, they can literally have an end-use product the next day, right? So talk about fast to market. You can be extremely fast when using these types of tools. So let's go through an example of how SLS can transform manufacturing. I like this example because this is something that we always try to do here at WB Engineering. We always try to simplify and optimize designs as we go in order to avoid a lot of issues in terms of quality checks, things like that, assembly complexities, costs associated with assembly, etc. So with the traditional manufacturing process, the part that you see on the screen right now requires 15 parts, 5 SKUs, 3 custom tools, and 10 assembly checks for a very seemingly simplistic part. Now, when you look at the 3D printed version of this, completely different story. You're able to generate geometry that previously would require 15 parts and 5 SKUs. Now, out of 1 part, 1 SKU, no custom tools, and 1 assembly check. Right. So this saves you a lot of time and money in the aspect of labor. It also saves a lot of money in terms of human error, right? So you don't have to worry about maybe somebody not checking the part properly in terms of assembly and then not checking it again in terms of quality, whatever it might be. You're limited now to just 1 point, which is far easier to manage than having to deal with 15 different checks, right? So it's a huge improvement when you're talking about being able to use these printers for end-use product, along with all the other ways that you can use these printers. But this is one of the more intriguing examples I like to look at. The other thing is you can start to create now very, very unique parts as well with geometries that never could have been done previously, right? So taking from the previous example, now we know that we can use this as an end-use part, so let's now leverage that, right? So now you have zero cost for tooling. So you can make very unique parts with very low volumes and it's still going to be economical. Where traditionally you need to make sure that you have a certain amount of need in order for you to produce a part, because you need to make sure you get your ROI on that part, being that you have to invest time in tools, you have to get stock orders for parts to get economy of scale, etc. So this is something where you no longer have to cut corners and you can actually make the design that actually works and not worry about the manufacturing process behind it. So next up, so complete design freedom. This is actually a little snippet that was taken from the SLS design guide by 3D Systems. It's actually, if you go to 3dsystems.com, then go to resources, you'll find some design guides there for 3D printing. But this is one of the ones that looks, let's say along the same lines of what we were just looking at. So this is just going into a little bit of details of what you should do if you're going to be using 3D printed part for end use. In this example, it's cool because it takes advantage of the technology to do a teardrop shaped pass-through for a mounting point. So it's nice aerodynamic teardrop shape, reduces turbulence and noise, and also improves airflow efficiency through the manifold. So it also says, apply generous fillets when you're going to be using this kind of technology, and that goes basically across the board when you're talking about injection molded parts as well. You don't want to put 90-degree angles on parts that are prone to have a lot of stress on them. You want to put a fillet there in order to be able to not have a very defined crack or weak spot on your design. So I'd say check out the design resources that 3D Systems has. It'll help you understand better the positives and limitations of 3D printing. So this is another cool example. SLS allows you to actually manufacture parts on demand anywhere in the world, right? So one of the cool examples I heard early on was with direct metal printing, that what they want to do, Boeing is already 3D printing certain parts for planes right now, and one of the plans is to actually have metal printers in different parts of the world. And let's say you have a Boeing that is in Shanghai, China, is missing a certain part that's only available in the headquarters of Boeing. Well, all they have to do is send over an STL file, have it 3D printed, and then they can install it as opposed to having to mail something across the world. So that's one of the cool parts here. The other thing is you don't have to have physical inventory. It can all be digital. In the example that we have up here on the screen, the F-35 strike fighter actually has more than 300 3D printed parts on it. So this is actually being used, and people are trusting their lives with this. So 3D printing is no longer something that is very far-fetched to use for end-use product. It's actually being implemented where failure is not an option, which is up in the sky, right? So definitely don't want to be risking somebody's life with the technology that you're not certain with. So 3D printing has already earned the trust of the military, Boeing, and a lot of reputable medical companies as well. So if you're curious about how reliable and how effective 3D printing is, I mean, you can search the internet, you'll find endless amounts of examples of people using 3D printing and getting huge benefits out of it. This is another example here, patient-specific instrumentation, so implant instrumentation, so you can actually make very customized implant guides, things like that. You can sterilize them before you go in there to the surgery, so you can do better fit, minimal invasive, and faster recovery time for surgeries. In my undergrad years, when I was in school as a biomedical engineer, I actually had to sit through an orthopedic surgery, which was extremely, extremely gruesome. It looked like a carpentry / butcher shop. And the doctor had to grind down a person's knee in order to fit, I'm oversimplifying it, right, a small, medium, or large kneecap. Those days are now starting to fade, where now you can actually get an MRI CT data of the person's knee, and then you can actually direct metal 3D print the part so that you have a full custom knee, less trauma, faster recovery, etc. So not only can you print out guides, you can actually print out parts that are going to be surgically implanted. So that's with direct metal printing, which we'll be doing another webinar on, but I just wanted to fill you guys in on that. The other thing is mass customized industrial design. So this is another product that you go to Amazon.com, you can actually find 3D printed cell phone cases and jewelry, and in some cases clothes that's ready for end use, right? So if you're looking at other types of technologies, you might not want to sell it as end use parts if it's something that's going to be taking a lot of wear and tear from the user, unless it's from an SLS machine or a direct metal printing machine. So another poll here, just to make sure everybody's still with us. So I'm going to go ahead and ask real quick before you guys forget. I should have asked this a little earlier. So if you guys look at all the SLA systems that we just looked over a little earlier, which one do you think was going to best suit your needs? So it's basically the answers go from small to big. Now, I probably should have pulled this up earlier, so I apologize. So we start off with the ProJet 6000 being the smaller footprint SLA printer, all the way to the Pro X 950 printer, which is a larger footprint. So if you don't quite remember what printer is what, I guess what you can do is just look at the three options and just think of it as small, medium, medium large, and then extra large. All right, I'll just wait a little bit more until we get a couple more votes in. Again, so for those of you that are still thinking, just think of it as your option A being small, second one medium, third large, last one extra large in terms of build volume. They all have basically the same capacities with the exception of material options that are available to them. All right, so I'm going to close out this tab now. Thank you very much. So how does SLS work? So this video actually doesn't have audio, so don't try to adjust your computer. Works basically the same way as SLA does. Difference here now is instead of having a liquid resin, what you have is actually powder or core kind of material. Depending on what material you have, that's the material that's in there, and then a laser actually go ahead and solidifies or fuses the parts together as it prints. Starts dropping down into itself. The good thing about this is that it doesn't actually require any support at all. Where with SLA, we had minimal support structures. With SLS, zero support. So here's the actual build volume on the inside. This is actually what you see when you're done with your print. The post-processing is basically just digging your part out of a vat of material and then sandblasting it. So these are considered industrial printers, right? So you are going to have some dedicated facility for this. Some of our customers that do have these printers have the same person that's running the machine shop or running any other machinery that they might have there run this as well. So you don't need full-time staff, but if you are going to be running it full-time, you will have to have somebody that's going to be dedicated to cleaning out the parts as well. So again, very, very durable parts in a wide range of materials. Okay, so now with 3D printing, with SLS, we have very, very good mechanical properties here, right? So we have an overlay here of our Duroform Pro X material, which you'll see outlined in red. We're comparing it with polypropylene and also ABS and also PP plus 20% talc, right? So you notice that we have very, very good flexural strength, tensile strength. Only place that we're falling a little short is elongation at break, right? But other than that, very, very robust, strong material. Functional prototypes, I know that's one of the things that a lot of our customers start off using 3D printers for. Well, this is very good when it comes to mechanical properties and comparing it to actual injection molded material. So in this example, it's a car seat. One was injection molded final product, which is the one on the left. The one on the right is actually a 3D printed version of it directly off of the machine. So you notice that the actual stress strain curve or the impact that this chair took was nearly identical between the production version and the SLS printed version. That says basically that you can test your part before you have to cut steel on it, which is nice because then you know you're in the ballpark before you actually start making all that investment and waiting all that time to get your tool back, inject it, and then see what's happening. Then if you end up in a situation where you have to make some changes, just make the changes, reprint, as opposed to when you already have the steel cut. That can be a big issue. So why would you choose Pro X 5000? It has unrivaled material recyclability. There are other SLS systems out there on the market. We recycle the most amount of material back into your machine. Other systems require a high percentage of fresh material to go back in. So we can recycle more than the competitors. There's very little waste. There's no supports there. So and also these things are workhorses, right? So there's very low maintenance costs as well. So the part cost is reduced by 40% on our system as opposed to other SLS competing systems. Now, speed and throughput, we compared it in this slide to FDM printers, which would be your Stratasys style printers, which are one of our competitors with in terms of large, robust parts, right? The Pro X 500 is far faster than an FDM printer, extremely fast, up to 7 times faster compared to FDM, and then also you have less post-processing time. So the FDM parts, either you have to leave it in a vat overnight to dissolve off the material, or and also you have to pick off the material once you're done, where in this you break it out of a cake and then you sandblast it or bead blast it to get the material off of the remaining material off of the part. So it's relatively fast post-processing and extremely fast print time comparison. So let's go over a couple examples of throughput. So the baby chair car seat is 34 hours to build. 240 mobile printer covers is 80 hours to build. Then we also have bridges for car for handicapped people. That was 52 hours. So these are taking up basically the entire build volumes, and you have several day prints. But the good thing is, even though the printer's taking a couple days, in terms of man time, that thing's running unattended, right? So that's one of the beauties of 3D printing. You don't have to do setups and change ups like you would on CNC machines. So there's a lot of different materials available: Dualform, Pro X glass filled. There's also aluminum filled. There's high impact polyamide. So there's a the amount of strength that these parts have. So looks like you might have lost audio there for a second. I hope not for everybody, but I apologize. Okay, so what's happened with the Pro X 500 recently? So the materials have been improved. There's improved overall toughness, and there's also significant improvement in Z toughness as well. So with 3D printing, unfortunately, physical properties or strength in X, Y, Z in some cases differ a lot, in some cases differ less. So if you're looking at something like an FDM printer, that's like wood grain, right? So in one direction, very strong, another direction, very easy to break. With SLS, not so much. Same thing with SLA as well, not so much as either, because the layers tend to fuse into each other a lot better than with FDM technology. So this is just a quick overview of this material. Pro X material is highly elastic. The Dualform Pro X material also enables you to do living hinges and easy fits. Next thing is you have other materials. Looks like this one might be a copy. I apologize. This might be a duplicate. Oh no, it's not. All right. So we're looking at glass filled, aluminum filled. So aluminum filled can do high strength to weight ratio parts. You can also do cast aluminum aesthetics. You can do jigs, fixtures, but then again, you can do jigs and fixtures with the glass filled as well. It doesn't have to be necessarily aluminum filled unless it has to be extremely, extremely strong. You have high impact, a lot of different details. The next thing is you have smoother finishes on the sides. They've improved the resolution on the Pro X 500 to 0.45 millimeter resolution. There's improved scanning for the system and thermal control, which essentially is build methodology that it uses. It also has 64-bit processing, which allows for larger print files, so if you're getting real funky organic shapes. So here's some tech specs about our Pro X 500. We have 15 by 13 by 18 build volume, and then also there's different scanning speeds between the standard and the plus. Excuse me. The plus has additional resolutions of print in, etc. So summary: durable parts, also fast build speeds. You have the best-in-class surface finish when it comes to SLS. A green process with very little material to waste, right? So we recycle a lot of the material. We don't require very much new material to go in between builds. Furthermore, the support material is all reusable. And then also you can reduce the amount of parts, reduce part manufacturing costs, which enables low volume manufacturing applications. These are our other selections that we have. So we have the Pro X 500, which was on the left, and we have up to our larger SLS printer, which is the S Pro 230. Slight variations in material offerings. So the last question, I know I'm running a little bit over on time now. Which SLS printer best suits you guys? So I know it's a little bit of a hard question, meaning that I just introduced them on the last slide, but again, you're basically looking at small, medium, large, extra large. So if you guys can just cast your vote real quick, and we will be done. Okay, just going to wait a little bit more till we get a couple more votes in. And I'm going to go ahead and close this out. So that said, everybody, thank you very much for hanging in there. I really appreciate you guys taking time out of your day to learn a little bit more about SLA and SLS printing with us at WB Engineering. If you want to contact us, feel free to send us an email at sales@wb-3d.com, or you can give us a call directly at 305-756-4401. So if you have any questions, again, feel free to email us, give us a call. We're more than happy to help you out. We are continuing with our web series. We will follow up with an email after this, thanking you guys for attending, and then also with invitation to join us at our next webinars. So the upcoming webinars are going to be for direct metal printing, and then we're going to be doing one as well for color. So I believe the color printing one is up next, and then our last webinar of our 6th series webinar is going to be on metal. So thank you very much, everybody. Appreciate your time. You guys have a good day.